We are going to learn about function notation today. So we are on slide 32, and we are going to go on to slide 33, where we're actually talking about what function notation is. Think of a function as a machine. A number goes into the machine, which if it goes in, that's an input. The machine performs the operations requested, and then a number result comes out of the machine, or the output. In function notation, the expression following f of x describes the operations a function machine will perform. Try one below. So let's look at this function. F of x equals 2x. If we have f parentheses x, that's the name of the function. F is the name of the function. It could be g, it could be h, it could be m. There are different names of functions. So this one's just called f for function. And then x is our variable, that is the input, the independent variable. And then the 2x is actually what you're going to do as far as what operations to do. So you're going to multiply 2 times whatever x is. So in your composition book, we are going to write some things and work out some functions. So open up your composition book and label the next page. Function notation, slide 33. Do you have pass or anything?
No, we didn't say anything. I was in the nurse.
Oh. I need to pause this if I can get to it. Hello? Hey. Okay, so function notation. Let's look at what the function is. That first function was, let me pull it up, was f of x equals 2x. So if we have f of x equals 2x, then that means I'm going to input a number for x, and the output is going to be 2 times whatever the input is. So I'm going to input a number for x. So let's say that x equals 2. So see how x is in the place of 2 is in the place of x. So that means I'm going to do 2. Anytime you input it, put it in parentheses. So instead of writing x, I'm going to put parentheses 2. So 2 times 2 be 4. So when x is 2, f of x or y is 4. So we're going to write this as an ordered pair. X, y. Where the y is the function of x. So we can use these interchangeably. F of x is y. X is just x. So if I inputted 2 for x, so then my x is 2, but my y or my f of x is 4. So let's say f of, let's see about negative 2. If we do f of negative 2, I still have the 2 as part of my machine or my function, but in the place of x, I'm going to put a parentheses negative 2. So I'm multiplying 2 times negative 2 and get negative 4. So then my ordered pair of what x and y are in an organized ordered pair, it'd be negative 2 and negative 4. Okay, so let's look at the other one. 3 is going into the rule. G of x equals 3x minus 1. So let's write g of x equals 3x minus 1. And so it says we are going to input in here a 3. And so we want to know what the output is. So we're going to write g of 3 equals, anywhere I see an x, I'm going to plug in the 3. So 3 times 3 minus 1. We can do this in our head. We can do it on paper. We can check it in our calculator. We can do it in our calculator. You have to decide what's best for you. So I'm going to show you how to do it without putting in your calculator. We got to follow order of operations. So parentheses, exponents, multiply, divide, add, subtract. So multiply is first. So 3 times 3 is 9. And 9 minus 1 is 8. So that means that when x is 3, f of x or y is 8. Okay, let me show you another one. I'm just going to come up with a h of x, just a random one. And I'm going to say that h of x is 4x squared plus 2x. So this one has 2. It has an x here and it has an x here. We're going to plug in 3. So h of 3. So anytime I see an x, I'm going to plug in the 3. So this will be 4 parentheses 3 squared plus 2 times 3. So we can solve this out using our head, writing things down, or in the calculator. When you do order of operations, which operation do you do first? Think about PEMDAS. Parentheses, is there anything that can be done inside parentheses? No. So then the next thing is exponent. So you do this first. So you do 3 squared is 9. So 3 times 9 plus, oh yeah. No, thank you for catching that. So it'd be 4 times 9 plus 2 times 3. So we did exponents. There was no parentheses that we had to do inside. So then multiply and divide, add, subtract. So we got to multiply first. So 4 times 9 36. 2 times 3 is 6. 36 plus 6, 42. We can do this in our calculator though. So get out your calculator that's either on your Chromebook or you can grab one of mine from the back of the room. And we're going to put this in. So we'll put in this. 4 parentheses 3 squared plus 2 times 3 equals 42. So we could write this as we plugged in, the input was 3 and the output was 42. Okay, so let's move on to slide 34. It says let f of x equal x squared plus 3 and g of x equal 3x minus 1. Let's write those down on our composition book. F of x equals x squared plus 3 and g of x equals 3x minus 1. And so we're asked to do some functions. So I'm going to pause it. I'm going to let y'all do the first 1, 2, 3. So do these 3 by plugging in to the functions. I'm going to pause it. Okay, so hopefully you've done the first 3 or 4. So let's see how you did. So f of 3, you would plug in the 3 for the function f. And we can actually just work this out. 3 squared is 9. 9 plus 3 equals 12. So we could write this as an ordered pair. When x is 3, f of x is 12. Okay, and then g of 3, we're going to plug in g over here. 3 times 3 minus 1. 3 times 3 is 9. 9 minus 1 is 8. So for g of 3, we get 3, 8. So it had a different machine, different operations. Okay, f of negative 2. So we would plug in negative 2 here. So it'd be negative 2 squared plus 3. Okay, you have to have this in parentheses. That's why I'm having y'all do it for all the problems. Put it in parentheses. Because negative 2 squared is different from no parentheses in there. So negative 2 squared means negative 2 times negative 2, which is a positive 4. Plus 3, which gives us 7. And you can verify that in your calculator. Negative 2 squared plus 3. If you don't put the negative 2 in parentheses, look at how you get the wrong answer. That's because that negative doesn't get squared. When you do a negative squared, it becomes positive because negative times negative equals positive. So this one is the correct one. This one is incorrect. It is not -1. Get used to putting it in parentheses. Okay, so then that means that this is -2, 7. Okay, G of 0. 3 times 0 minus 1. 3 times 0 is 0. 0 minus 1 is just -1. So it'd be 0, -1. Okay, let's look at, I think we're going to do 1, 2, 3 more problems. Let me see. Okay, so we've done these. So now we're going to do f of 2 plus g of 1. No, we're only going to do 2 more problems. And then g of -1 plus f of 1. So we're going to do these 2. So we have to do f of 2 and then add it to g of 1. So we need to do them separate. So find what f of 2 is and then add it to f of g of 1. So f of 2, let's see, x squared plus 3. So it would be 2 squared plus 3. So we got to do 2 squared is 4. 4 plus 3, 7. But we're not done because we need to do g of 1. G of 1 is found by plugging in x, 1 for x for the g function. So 3 times 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. So the question tells us f of 2 plus g of 1. So that means I'm just going to add these together. So 7 plus 2 is 9. And we can't write this as an ordered pair because we actually did 2 different functions. So we wouldn't have one ordered pair. We have them added together. Go ahead and do the next one. Okay, g of -1 would be 3 times the -1 minus 1. So 3 times the -1 is -3 minus 1. You can do that keep, change like that. And you get -3 plus a -1. Yeah, -4. And then f of 1, 1 squared plus 3. Should be 1 squared is 1. 1 plus 3 is 4. And then you add them together. So it says g of -1, so that's -4, plus f of 1, +4. -4 plus 4, what does that equal? Yeah. Okay, I want you to take a picture of this and insert it in on that slide. We're going to finish the rest of the slide tomorrow, as well as do a few more notes. And then your assignment is in Delta Math. It's called Function Notation Day 1.